We're going to discuss quadratic inequalities today. These are the topics we'll cover. Now, quadratic inequality is very much related to quadratic equation. Your quadratic equations are ax squared plus bx plus c equals 0. To get an inequality, we simply exchange the 0 or replace it with an inequality such as less than, greater than, less than or equal to, or greater than or equal to. Now, the first step in solving any quadratic inequality is to actually solve the quadratic equation. We actually are going to solve, even though these are less than or equal to or greater than or greater than equal to, we're actually going to solve the equal to part first, because this yields the boundaries to the solutions. And the reason we have boundaries to solutions is because in inequalities, our solutions are actually intervals. Let's look at this concept graphically. This graph is the function y equals x squared plus 2x minus 8. If we were to actually solve 0 equals x squared plus 2x minus 8, we get two solutions. We get x is negative 2 and x is 4, which correspond to the two x-intercepts on this graph. If we wanted to solve x squared plus 2x minus 8 is less than 0, this is the solution of all values of x between negative 2 and 4, because this is the part of the function which gives me a negative answer. If I plug in a number between negative 2 and 4, this gives me a y value which is negative. Notice this is all below the x-axis. So our solution would actually be from the interval negative 2 to 4, because every value between x value between negative 2 and 4, pick an x value, say 0, plug 0 into y, you get negative 8. You plug any other x value between negative 2 and 4 into this equation, it's negative. So therefore the solutions of this one, x squared plus 2x minus 8, are everything between negative 2 and 4. Now, how do we solve this without graphing it completely? First step is to make sure the inequality has all non-zero terms on one side and 0 on the other side. In other words, I get everything to one side. We want to factor the polynomial to get your boundary points. We want to set up a number line with your boundary points, and we want to plug in test points. The intervals that agree with the inequality are going to be part of your solution. Let's see how this works. We have 4x squared plus x minus 5 is greater than 0. Everything's already on one side, so I'm simply going to factor. This factors to 4x plus 5 times x minus 1 is greater than 0. So the solutions to the corresponding equation would be negative 5/4 and 1. So I'm going to set up a number line. Here's my number line with the numbers negative 5/4 and 1. This gives me three intervals. This interval to the left of negative 5/4, the interval between negative 5/4 and 1, and the interval from the right of 1. All I care about are test points. I'm not going to test every point in the interval. I just need one point in the interval. Because if I can find out if one point in the interval is positive, every point in the interval is positive. If one point in the interval is negative, every point in the interval is negative. The reason this works, if you look at a parabola, these are all your positive answers. Then once it goes past this 0, they're all negative. And then once it goes past this 0, they're all positive. In other words, on these intervals, you're either all going to be positive on the intervals or you're all going to be negative on the intervals. It's not going to switch back and forth across this x-axis. So let's pick test points. I'm going to pick easy ones, negative 2 on this side, 0 in the middle, and 2 on the right. Negative 2 is to the left of negative 5/4, 0 is between negative 5/4 and 1, and 2 is to the right of 1. And all we're going to do is plug into the factored form. When we plug in, all we really care about is whether it's positive or negative. So let's plug in negative 2. Negative 2 into here gives us a negative 8 plus 5 is negative. Negative 2 minus 1 is negative. A negative times a negative is a positive. So everything to the left of 5/4 is positive. Let's plug in 0. 0, this becomes a positive 5 times negative 1. A positive times a negative is a negative. So everything in between negative 5/4 and 1 yield a negative answer. Let's plug in 2. 2x plus 4 times 2 plus 5 is a positive number. 2 minus 1 is a positive number. A positive times a positive is a positive. My solution says everything greater than 0, so I care about the positive areas. Okay? So things that make this greater than 0 are the left interval and the right interval. So from negative infinity to negative 5 fourths, so from over here up to negative 5 fourths, and from 1 to infinity. So my answer is negative infinity to negative 5 fourths union 1 to infinity. Another example, we have x squared is less than or equal to 2x plus 35. Again, our first step is get everything to one side, so x squared minus 2x minus 35 is less than or equal to 0. This factors to x minus 7, x plus 5. So I would actually solve this. The two solutions will be x is negative 5 and x are 7. So here's my number line, negative 5 and 7. I got to pick test points. Easiest test points are negative 6, 0, and 8. 0 is always your easiest, and then when I get up to the right of this number and to the left of that number, I try to pick one that's really close, so I'm not going way far out. Let's plug in negative 6. Negative 6 minus 7 is negative. Negative 6 plus 5 is negative. Negative times negative is a positive. Plug in 0. Negative 7 times positive 5 is a negative, so 0 yields negative results. Plug in 8. 8 minus 7 is positive. 8 plus 5 is positive. Positive times positive is a positive. I'm looking for where this is less than or equal to 0. So I'm looking for where it's negative. Where it's negative is in this interval in the middle between negative 5 and 7. And it says less than or equal to, so I use close brackets on each end. So this is the interval negative 5 to 7, including both negative 5 and 7.